Good day, everyone. So we're going to talk about section 1.2, sample versus population. And before we talk about samples and populations, we're going to talk about subjects first. All right, so what are subjects? Those are the entities that we measure in a study. And so that means subjects can be either individuals, so it can be either people, or it could be things. Okay, and it's just the things that we went ahead and gathered information about. Okay. All right. So those are subjects. How about populations and samples? Here's a population. Here's the definition. It says the total set of all things, subjects or things in which we as researchers are interested in learning about. So the first thing is that, let me get my pen out, is that the way I approach this course is that we're researchers. And so when we get to some more complicated problems later on in the semester, we're going to take it from the vantage point that we are the researchers. Okay, and we're trying to learn about something. All right, and we're going to use data to learn about it. Okay, and so the researcher defines the population. So a lot of times when we think of a population, we think of the population of, say, the United States or the population of the world. Don't think of it just as that. Now, some problems might define the population like that, but other problems will define it in a lot smaller group of people or group of things. For instance, maybe we're a medical researcher and we define a population for a particular problem as all the people that have colon cancer, okay, or all the people that are nearsighted, okay, and so on and so forth, okay. And so it's just however the researcher decides to go ahead and define things. And the researcher can actually define more than one population. And so let's say that you for one problem, we might look at all University of Akron students. For another problem, we go ahead and separate the males and the females. And so we have all male University of Akron students, we have all female University of Akron students. If that's the case, the researcher has now defined two populations. Okay? And so it's just how the researcher has defined things. Now, the other thing that I want to point out is the word all here. All right? And so that's giving you a clue that we're talking about a population. So a lot of the problems that we do, we say, we'll use the word all, and what the problem is trying to convey to you is that, we're talking about a population of something, okay? All students from a particular high school, okay? Or all people that drive, or all people over the age of 60, okay? Once you hear that, that's the population in our problem. What about a sample? Sample is a subset. Now, if you don't like the word subset, think of it as a portion. Okay, we're talking about a portion of what? The population, and from which information about the population is obtained. Okay, so the whole purpose of taking a sample isn't just to learn about the sample. It's actually, the bigger picture is so that we can take the sample information and apply it to the entire population. So we take sample information and apply it to the entire population. Okay, so you're going to see that throughout the semester. Okay, so we're always trying to learn about a population. So think of it like this: is that we have a population out there, and we have all these things, we have all these people. Okay, like I said, it could be people or things, and so we got all kinds of different subjects in here. Okay, in our population. Okay, but we're not going to look at the entire population. This is a lot of people to take a look at, right? So we're not going to look at the entire population. Okay, what are we going to do instead? We're going to take a random sample, or we're going to take some sort of survey from this population. So we're not going to look at the entire population. Okay, so what are we going to do? We're going to just take a couple of people here or there, right? Now it's going to be more than 4. Okay, but think of it that maybe we look at 50 or 100 or 200 people from this population, okay? And then we're going to bring those people into the sample, all right? So notice the sample are people that come from the population, okay? And the whole purpose of taking the sample is to do what? It's to learn about this guy right here. It's to learn about the population, okay? To learn about the population. So that's going to, like I said, it's going to be a theme throughout the semester, especially once we get to chapter 8. Excuse me. So we have this idea of descriptive stats. So descriptive stats refers to methods for summarizing the collected data. So summaries like graphs and averages and percentages and tables and things like that. And so remember in section 1.1 when we talked about the halftime stats, okay, that would be descriptive statistics. And we do that in this class. We do it in chapter 2. But that's not the focus of this course. You've been learning descriptive statistics since 5th, 6th grade. Okay, you've been doing that for a long time, calculating averages, calculating medians, calculating modes. Okay, that's why you've been learning them, is to learn them so that you have an idea when you get into a stats course. But we don't use descriptive statistics by themselves. We calculate these descriptive stats so we can do what's called inferential statistics. And inferential stats, this is why you guys are here. That's why I'm putting a little asterisk here. Okay, maybe I'll put even a bigger one here. So this should actually get 5 asterisks. So inferential statistics refers to the methods of making decisions or predictions about a population. There it is again, about a population. All right, based on data obtained from the sample. All right, and so inferential statistics is making predictions, decisions about what? About a population. Okay. Now here's a sobering fact: is that unfortunately we have to get through 7 chapters of background information first before we actually do inferential statistics in this book. We don't get into inferential statistics until chapter 8. But if your major is having you take this course, it is not to learn about descriptive statistics. It is actually to learn about inferential statistics, right? So that's truly the focus of this course, is how to do inferential stats. Okay, let me give you an example. So for a presidential election, we randomly polled 1,000 potential voters, and 58% said that they would vote for the incumbent. So what I want to do is that in terms of the problem, so I don't want you to give me the definition of a population or a sample. I want you to go ahead and define it in terms of this problem. All right. So what we'll do is we'll start with the sample. Now, why do we want to start with the sample? Because that's what's going to be defined and very distinctly in the problem itself. All right. And then 2, we want to define the population. Okay, based upon that sample. All right. And so let's see here. The sample. Well, how many people did we take a look at? Or things. Here we took a look at people, right? We took a look at 1,000 what? Potential voters. So our sample is 1,000 potential voters. That's it. So the sample is going to have a number associated with it because this is what we call the sample size. The sample size. Okay, the sample size is the size of the sample. All right, it's the number of people or things that we took a look at. All right, and so so we're always going to have a number with it. Okay, now don't put just 1,000. You know, if you put that on a test and you wrote in 1,000, I'm going to say what, 1,000 first graders? No, it was what, 1,000 what potential voters. So we need a number and some sort of description after that. Then, based upon that sample, okay, we can define the population. And so if we took a look at 1,000 potential voters, what's our population? Our population is all potential voters. Okay. See, we're not interested in just 1,000 potential voters. Okay. We're interested in taking that information and applying it to the entire population somehow. Okay. And notice I use the word all to represent population. Okay. To represent the population. So, so basically, to go from one to the other, you would just take your number, your sample size here. All right. Change it over into the word all, and then put your description there, and that should define your population. So if we took a look at 100 first graders, well, that means all first graders, okay, would be our population. Okay. All right. Let's move on. Was this descriptive or inferential statistics? Now be careful. So maybe you need to pause the video, and think about it, and then come back once you're ready, once you've thought about it. So hopefully you thought about it. So which one is it? Is it descriptive or inferential? So be careful, okay? Here, always said that 58% said they would vote for the incumbent. Well, that just means the 1,000 potential voters, okay? And so Did we apply it to the entire population yet? Did we apply it to all potential voters yet? No, we did not. All we did is describe what was in the sample. Okay? Describe. Descriptive. That is descriptive. So you might ask me, well, hold on. How could we change that to inferential? What would we see in order to see inferential? Well, okay. So let's change it around a little bit. So it says here, for a presidential election, we randomly polled 1,000 potential voters. Based on this, so based upon the sample, we believe that about 58% of all potential voters will vote for the incumbent. Okay? So notice, what did we do? We went ahead and applied it to all potential voters. We applied it to the entire population now. Okay? We took sample information and applied it to the entire population. And so once you do that, now you've done inferential statistics. Now we got to get more sophisticated than this, and we will. Okay, this is just kind of giving you the idea, plant the seed of that. This course is all about inferential statistics. The other thing that I want to point out to you that is going to play a part in Chapter 7 in this book is that I used here, we believe that about 58%. Okay, and so we took a sample of 1,000 people. Did we expect that 1,000 people to match the population perfectly? The answer is, well, it could, but probably not. Okay, but should it be close? Well, what we're going to find out, as long as we did it randomly and as long as we had a reasonable sample size, it should match the population fairly well. Okay, but it's not going to match it perfectly, so that's why I use the word about. It could be a little bit lower. The actual population of people that actually voted for the incumbent could probably be what? A little lower, or what? A little higher. Okay, so that's why I use the word about. So, was this descriptive or inferential? It's inferential now. Why? Because we took our sample information and applied it to what? All potential voters, the entire population. Okay? All right. So let's take a look at another one, just to make sure. So we can study the results from a random survey of 200 U.S. adults. We recorded that 18 out of the 200, or about 9%, or I shouldn't say about 9%, that was 9%, the survey were left-handed. There should be a hyphen here. I just realized that. It should be hyphenated. Anyways, so what was the sample? What was the population? Okay. All right. So what do you think here? What would be the sample? Hopefully you said 200 U.S. adults. What would be the population? We would change the 200 into the word all, and we have all U.S. adults. Okay. Now, in a real study, the researcher actually defines the population first, and then works back to his or her what the sample should be. Okay, but in these problems, we're going to be defining the sample probably, and then you get to work back to the population. But in the real world problem, it's actually the opposite. You would define the target population first, and then work your way back to the sample. So is this descriptive or inferential? What do you think? So did we apply it to the entire population yet? It doesn't look like we did. We just described what was in our samples. So that looks like what? Descriptive still. So how could we change this in order? Oh, no, look at that. I put the hyphen in there. So how can we change this in order for this to turn into inferential? So let's see here. Let's get rid of the second line, all right? And let's change it over to this. So we can study the results from we think that about 9% of all U.S. adults are left-handed, based upon our sample, right? And so now this is inferential. Why? Because we went ahead and applied it to the entire population now. Okay? All U.S. adults. Okay? Okay, so we have sample statistics and population parameters. So a parameter is a numerical summary of the population, okay? And a statistic is a numerical summary of a sample taken from the population. So in other words, parameters come from, so here's the cool thing, is that parameters start with a P, and they come from populations. Statistics, they come from samples, and they both start with S. Okay, so parameters come from populations, statistics come from samples. Okay, So now, the only way to know the exact value of a parameter is to take a census. And what's a census? A census is looking at the entire population. Okay? Excuse me. In the United States, we take a census every, 10 years. Why do we only take it every 10 years? Because it costs so much money. It takes a lot of time to do it. Okay? And it's quite inefficient, but we're by law, we have to do it. Okay? And so we go ahead and do it, but we only do it every 10 years because it costs so much. Okay? So as researchers, we're not going to take censuses. We're not going to take a census. We're just not. Okay? It costs too much money. It's very impractical. Okay? We can learn a lot about the population just by taking a random sample. All right? So to know an exact value of a parameter, we have to take a census. Okay? It's the only way to know it. But like I said, we will rarely ever take a census in the real world as a researcher. Okay? If you did, you don't need statistics. What do we do instead? We take a random sample, we calculate statistics, and then here's the key. We use the statistics to estimate the parameters. We use things from the sample to learn about the population. So we calculate statistics coming from samples to learn what? About the population, about those parameters. Okay? So we use stats to estimate parameters. So remember our exit poll. Okay? So let's continue here. So for the poll, we found 58% of the 1,000, okay, voted for the incumbent, okay. But then after the election, we find out that 55% of all voters actually voted for the incumbent, okay. So I want you to think about this, okay. The statistic here is the 58%. That's the thing that came from the sample, okay? Can you think of what the parameter is? Now, I told you that rarely do we actually measure the entire population, but for a presidential election, we actually know the results afterwards. We know everybody who voted. We can count the votes up. We can count the number of people that voted for a particular candidate. We can figure out the percentage of people that voted for that particular candidate, all right? And so it's one of those rare times that we can actually calculate a parameter. So the parameter in this situation is what? The 55%. After the election, therefore, everyone has voted. We took a census. Okay, everybody who was going to vote voted. We can count it all up. We found out what? That 55% of all voters voted for the incumbent. So that 55% would be the parameter. Okay, the statistic was the 58%. Percent that came from the sample. So we use the statistics to understand the parameters. Okay. And do you think that's a reasonable result? If we got a statistic of 58% in our sample of 1,000 people, that the parameter could actually be 55%? Yeah, it could be a little bit higher. So if we took a random sample, okay, and calculate a statistic, the actual parameter, if we could look at it, is probably could equal the statistic, but probably not. It's probably going to be a little bit higher or a little bit lower. Okay. So I want to get something across to you. I kind of want to plant a seed for later on in the semester. Measurements may vary from person to person, and just as people vary, so do samples vary. Okay. So that means statistics also vary. So if you think about this, all right. You got these different news organizations taking these political polls, all right, and you got so they ask 1,000 people. So one poll says, okay, 48% of the voters from the sample is going to vote for this particular candidate. Well, another sample of 1,000 people. Remember, there's probably going to be a different 1,000 people. Maybe 46% of that one is going to vote for that particular candidate. And another sample said 47%. And another one said 49.2%. Okay, so these statistics that are coming from these samples can vary, okay, and they will vary. And how they're going to vary? From sample to sample. Okay, we're going to study that in Chapter 7. Okay, but our main focus right now should be population, sample, what's the population, what's the sample, all right? Is it inferential or descriptive, okay? And then understanding the difference between statistics and parameters. Thank you for your time.